Hello guys, welcome to my channel. So in this video I'm going to discuss about one of the gate subject, that is digital electronics, or we can say logic design, logic design or digital logic design. The names will be same, digital logic design. Okay, so we'll start with the basic the concepts of digital electronics. So here the part of the space I use for the to write the content. Okay, so the duality property in digital electronics. The duality, it is an important property in the Boolean algebra. So that is called the duality principle, that states that every algebraic expression that remains valid if its operators and identify the elements are interchanged. Okay, so the duality property. So what is the duality property? So x into x dash plus y is equal to x into x dash plus x y. So here, as per the rules of Boolean algebra, x into x bar, it is 0 plus x into y, so that is okay xy. Okay, means the function, these whatever the functions they are given here, the functions 1 and 2 are dual of each other. For example, here I have taken x into x bar plus y. Okay, so there is one more function x plus x bar into y. Okay, x plus x bar into y. So what is the operation here? So this we can write it like x plus x bar into x plus y. This we can write in this way: x plus x bar into x plus y. Okay, so x plus x bar means 1 and we'll get x plus y. So the function, these two functions are dual of each other. Okay, so dual of each other, these two functions. We'll see, you'll understand the basic concepts. Okay, so the Boolean functions. So Boolean function is described by algebraic expression. Boolean functions are described by the algebraic expression, so that consists of the binary variables. So the binary variables are represented as 0, 1. Okay, the binary variables are represented either 0 or 1. So a Boolean function can be represented in a truth table. So the number of rows in the truth table is, for example, here if there is a three variable, if there are three variables, then the truth table is 2 raised to 3, so that is 8 rows, 8 number of possibles. Okay, the number of rows in the truth table. Suppose if it is a 4 variable, if there are 4 variables, Boolean algebra, Boolean expression, Boolean function, then it is a 2 raised to 4, so that is 16 rows in a truth table. So here the truth table for the functions, okay, the functions f1 and f2. Okay, what are the functions? The f1 is x into y. Suppose x into, so here, okay, so the number of rows. Okay, so for here three variables are there, x, y and z. So for these the different combinations, so that is 3 variables means 0 0 0 0 0 1 0 1 0 0 1 1, that is 3. Then okay, it is 1 0 0 1 0 1 1 1 0 1 1 1 7 0 to 7, and based upon the functions we can write the value here. Okay, based upon the function, for example x y z. Okay, here the functions f1 and f2. So here the f1 is this is the function x plus y bar into z. Okay, x plus f1 means x plus y bar into z. So what is the x? X is 0 here. Suppose here in this case if you take 0 plus y bar means here 1, z is 0, so 0 only. So this comes to 0. So what about this one? Here x is 0, y bar is here 0 0, it indicates 1 here. Complement is there in the function. So 1 into z is 1, right? So it is 1. So that's why here the function it is written. So in this way you can write the truth tables. Okay, and here the gate implementation of this function. Okay, here f1 equal to x plus y bar. Okay, y bar into z. Okay, so how we can write this one? So here you can write like x. There are how many variables? Are 3 variables, x y z. Okay, and so here it is x and y bar z. So y bar, y is there, and with the NOT gate we will get a y bar. Okay, y bar and z. So which function is there here? Gate. This is and means here you write on the AND gate. Okay, and here, so here what we are getting here, y bar into z, right? So this plus this is x. Now this is x plus y bar z. Okay, so that is r gate you require to use. Okay, so this is the function f1. So in this way you need to write the here you need to write okay the function. So in logic circuit diagrams, okay, logic circuit diagrams, the variables of the functions are taken as inputs to the circuit, and binary variable f1 is taken as an output. So here in this case, okay, in this case what are the inputs? This is the input. Okay, this is called as input, and here the function f1 is output. Okay, so there is only one way that Boolean function can be represented in a truth table. Okay, however, when the function is in algebraic form, it can be expressed in a variety of ways. Okay, so here there is one more function they are given, the x bar y bar z plus x bar y z plus x y bar. So that is it is represented in the truth table f2 here. Okay, so here the take duals of the functions and complement the each literal. The complement of a function. So here the function f1 they are given as x bar y z bar plus x bar y bar z, and their dual. Okay, so here in this case the function f1 x bar y z bar plus x bar y bar z, and the dual of this function, dual of f1. What is the dual of f1? So here x bar, the product to sum you can consider x bar plus y plus z bar. So here the plus you replace with into x bar plus y bar plus z. Okay, so this is the dual of the function, and if you take the complement of f1, it is x plus y bar plus z into x plus y plus z bar. So that is f1 dash, that is complement of the function. Okay, or you can use, for example, here f1 is okay, so here this is the f1 function. Okay, f1 function x bar y z bar plus x bar y bar z. Okay, here complement means you can use in this way also. Means if we write x double bar equal to x, it is same as per the theorem, the property x bar x double bar equal to x. So here this you can write like, suppose a plus b whole bar means a bar into b bar, x bar x bar y bar z. And this you can write like x plus y bar plus z into x plus y plus z bar whole bar. Okay, so this you can write like x plus y bar plus z okay. We'll see in detail we'll see in detail about that. Okay, so here the next is canonical and standard forms. Okay, canonical and standard forms. See here there are three variables are there, x, y, z. The min term and max term. Okay, min terms are also called as product terms. Min terms are also called as product terms. Min terms are also called as product terms. Max terms are also called as sum terms. Max term is also called as sum term. Okay, so here as per the truth table, so 0 0 0. Okay, suppose here the x value, y and z. Okay, so here in min term we can write like, in min term x bar, y bar, z bar, and as a max term x plus y plus z. Okay, for example 1 0 1. So in min term x, y bar and z. So this is x, this is y bar, 0 is there, so we can write complement. And max term means, how we can write the max term? X plus y bar plus z. Okay. So here in max term means here for 101 it is, yeah, in min term it is 101. Okay, so here it is x bar and x bar, y and z bar. In max term it is, okay. So in min term we'll consider this as x, but in max term, okay, in max term x bar. Okay, for example 110 for min term and max term. Okay, in min term for x, y, z. Okay, min term x into y into z bar. Okay, in max term we'll consider this as x bar plus y bar plus z. That is in the max term. So sum of min term. Okay, sum of min terms. So here we will see one expression, f is equal to, so this is the one, there is one function f is equal to a plus b bar c as sum of min terms. So min terms means what? Product terms. So this is one term, this is one term. Okay, so here there are two terms are there, 1 and 2. So there is addition is there. Okay, addition. So that is sum of, these are the min terms, these are the min terms, and sum of the function is sum of min terms. Okay, sum of min terms. Here they given the function f is equal to a plus b bar into c, a plus b bar into c. So the first term, the function has three variables a, b, c. The first term a is missing the two variables, therefore, so there are three variables are there. Okay, so here this we can write it like a into b plus b bar, because b plus b bar means 1. Okay, so ab plus ab bar. So the function is still missing the one more variable. Okay, so that is c. So again this we can write it like ab plus, okay, here one term is missing, that is variable c plus c bar. C plus c bar means 1. Okay, plus ab bar, c plus c bar. So here we can write like this, abc plus abc bar plus a b bar c plus a b bar c bar, means we will get all the three variables. Okay, we will get all the three variables. So the second term, so this is about the first term that we took, this is the first, and now the second term, that is b bar c. So this also contains missing the one variable. Okay, so which variable is missing? A. So that is b bar c into a plus a bar. Okay, so this we can write like a b bar c plus A bar B bar C. Okay, so this is for the second term. Now you combine both. Okay, so this is for the first term, this is for second term, right? So now combine both. ABC plus ABC bar plus AB bar C plus AB bar C bar plus AB bar C plus A bar B bar C. Total 6 terms in the first 4 and next 2. Total 6 terms, and check whether is there any common. So this one. Okay, so this is a common. So here we will get final 5 terms. C bar, A bar C, A B bar C bar plus A bar B bar C. Total 5 terms we will get. Okay. So yeah. Boolean, this sum of minterm. For a binary variable, one can obtain the 2 raised to n distinct minterms. 2 raised to n minterms, and that Boolean function can be expressed as a sum of minterms. So the minterms whose sum defines the Boolean function and are those which gives a ones in the functions. Okay, which gives a ones of the function in a truth table. Okay, sum of minterms means that gives the one. For example here. Okay, so here this particular 111 in min terms means it is 111 110 101 100 001. So 001 means 1, then it is 4, 1015, then 1106, 1117. So these are the min terms. Means for these rows in a truth table it is 1. Okay, so here we can write like some of the min terms here. Okay, f of a comma b comma c is 1 4 5 6 7. Okay, here I'll write the truth table. 2 3 4 5 6. Okay, 6 and 7 means for this is a b c for these 3 variables. Okay, and this is my function, and what are the min terms here? 1. Okay, 1. Okay, 1 4 means here 5 6 7. Okay, so these are the, so this is the in this function. Okay, so 1 indicates it's a min terms. Okay, min terms. We'll see some of the gate questions. So before that, we'll just go through the some of the concepts. An alternative procedure for deriving the min terms of the Boolean function is to obtain the truth table. Okay, so here this is the truth table. Just now I written how we can obtain the truth table. Truth table for a given function. Okay, so here you can see for this one, for this a b c. Okay, here 1 min term. So 1 indicate there is a min term here. Then max term. Okay, max term. So each of the 2 raised to n function of n variables can also be expressed as a product of max terms. So here by using the distributive law, x plus y z is equal to x plus y into x plus z. So here we can so in min terms, sum of min terms will use to represent with this sum of 1, 4, 5, 6, 7 min terms. Okay, the function with one output in the truth table. So similar to that, we'll discuss further this max term. So what is the function? F is equal to x into y plus x bar into z as a product. Now it is in the sum of, see, this particular, it is a one product term, this is one product term. Okay, it is called a sum of product term. Okay, but we requires product of sum, past form, product of sum. Here you can see here product of, this is one. Okay, this is one product. Okay, product of sum. So here xy plus x bar z. Okay, so how we can write like the distributive law, x plus y z is equal to x plus y into x plus z, x plus y into x plus z. Okay, x plus y into x plus z. Okay, means it is equal. If this LHS equal to RHS, means both the terms are equal. So here what we can do is, with respect to this is the law. Okay, this is a distributive law. Okay, so with respect to here, so this function f is equal to xy plus x bar z. Okay, so this we can write like, okay, this how we can write this xy, this xy plus x bar, xy plus x bar. Okay, similar means we need to write like this. Okay, this is the first term and this is the second term. So x plus y into x plus z. Okay, in the similar to that, xy plus x bar. Okay, then into xy plus z. Okay, so here is x. Okay, xy plus x bar into xy plus z. Okay, so now, so here again this xy plus x bar, this again we can write like x plus x bar into y plus x bar. Okay, and here x plus z, again we are simplifying x plus z into y plus z. Again we applied the distributive law. Okay, distributive law. What is the distributive law? X plus y z is equal to x plus y into x plus z. We applied this law. Okay, so now you can solve. X plus x bar is 1, then we'll get y plus x bar, y plus x bar, x plus z, then y plus z. There are three terms are there. The three terms. So the function has the three variable. So function, actually this particular this function How many variables are there? 3. Okay, 3 variables. Okay, so 3 variables, so one variable is missing in each. Okay, so in this way how we can solve is, for example, x bar plus y, this first term I am taking. Okay, so here which one is missing? Z. X bar plus y plus, how we can add here? Here it is a sum, it's a product of sum. Okay, so pos form. So z into z bar is 0. Okay, z into z bar is 0, so there is no difference for this and this. Okay, so in this way we can include x bar plus y plus z. Again we are applying the distributive law, x bar plus y plus z bar. Okay, so now we got, so the distributive law is very important. Okay, distributive law is very important, you need to remember that. X plus yz, x plus y into x plus z. So this law will helpful for the product of sum term or creating. Okay, and here with the in a truth table for product of sum. Okay, if the output is 0, then we will consider those terms here. Okay, we will consider those terms. The output is 0. In min term it is output is 1. So here in this way we got for the first term. So here this is for first term, second term and third term. So combining all the terms and removing those which appear more than once. If there are some of the terms are repeated, then we'll remove those and we'll finally obtain. Okay, we'll finally obtain the 4 terms. Okay, so that will represent here sum of product and product of sum form. So we'll see some of SOP and pos form. Okay, so in canonical, okay, so here the min term and max term, we perform the sum of min term, that is sum of products and product of sum. In Boolean algebra, Boolean function can be expressed as canonical normal form known as min term and max term. Okay, so standard forms. The Boolean variable can be expressed in either true form or complemented form. The standard form of Boolean function. Okay, the canonical variables depends on the output of SOP and pos. So here min term of each combination of a variable that produces the one in the function, that is the output of the truth table 1. Okay, we will represent, produces a 1 in the function and then taking a OR for all those terms, sum of product. And max term is product of sum, each combination with the variable that produces the 0. So here you can see x, y, z, 0, 0, 0. The min terms are x bar, y bar, z. Max terms are x plus y plus z. Some terms or max terms. The terms and the naming is same, min term or product term, sum term or max term. So here the Boolean function a plus b bar c is as a standard sum in terms. Okay, so here a plus b bar c. The same example whatever we discussed just now. Here a plus b bar c. So total 3 variables are there, but in first term 2 variables are missing, and in the second term 1 variable is missing. So here how you can write a we can write like a into b plus b bar, so that is equivalent to this one. Then c is missing, so again we can write just now in this video we are discussed about that. Means it should contain all the variables. If there are 3 variable function, means it should contain the all the 3 variables in the function. So okay, so here sigma of 1 4 5 6 7, how we can represent the SOPs, sum of product forms. Okay. Okay, so this is about the like some of the min term, max term and all. Okay, so here just I will review about some of the terms that we discussed. So in the digital logic design, the terms sum of product terms, or we also called as min terms, and the product of sum, also called as max terms. Okay, max terms. And also you should know some distributive laws. Okay, the De Morgan's okay, so these are the different Boolean expressions and the law, that is Boolean algebra. 1 plus, okay, so 1 plus a plus 1 is 1, means any variable plus 1, so that is 1. Annulment law. Okay, any variable plus 1, that is 1, any variable plus 0, so that is the a variable. Okay, so a plus 0, a, identity law. Then a into 1 is a into 0 is 0, a plus a is a plus a, then a into a, not a means complement of a is a, and a plus a bar is 1. So we need to use these laws. This is a complement law. A plus a bar is equal to 1, then a into a bar is equal to 0, a plus b, this is commutative law. A plus b is equal to b plus a A plus B is equal to B plus A into B is equal to B into A plus B, De Morgan's theorem, A plus B whole bar is equal to A bar into B bar, A bar into B bar, then A into B bar, B whole bar equal to A bar plus B bar, De Morgan's theorem, De Morgan's theorem. Okay, A into B bar is equal to A bar plus B bar, then A plus B whole bar is equal to A bar into B bar. So these are both De Morgan's theorem. Okay, De Morgan's theorem. Okay, so these are the different laws that you need to use. Okay, you need to use in the while evaluating the Boolean expressions. Okay, then distributive law. So this is about the distributive law. A into B plus C is equal to AB plus AC. Then A plus BC, that A plus BC is also written as A plus B into A plus C, distributive law. So this is OR distributive law, and this is AND distributive law. Okay, A into B plus C, that is A into B plus C, no, that is AB plus AC. Okay, AB plus AC. See how these are equal means we can verify with the truth table. See, for example, 3 variables are there. This is A, B, C, 0, 1, 0, 1, 0, 1, 1, 0, 0, 5, 6, and 7. Okay, so this is the 3 variable, and here we can prove. So what is the first term? A into B plus C. So here I will just go with B plus C, and here it is A, and there the first term. Okay, first term. So here B plus C means it is 0. B plus C, only B and C you need to add. Okay, 1, 1. So 1 plus 1, 1, 0, 1, 1, 1. Okay, then and you need to add now this with A. A means here 0. This and this you need to add. So it is 0. Then with 1 with 0, 1, 1 with 0, 1, 1. So here it is 1. Okay, fourth 1 plus 0, 1, then 1, 1, 1. Okay, so now you need to add both A into BC. Now product. Okay, this is BC, B plus C and A. If one of the value is 0, then output will be 0. So this is for the first term. So similar to that, you can go for like AB plus BC to prove second term. Okay, so what is AB? A into B. So A into B means here you will get all the zeros, and here 1, 1. Then A into C. So A into C, one of the is 0, 0. Okay, and later you can add. I think here some mistake is there. B plus C. A into B plus C. Okay, 1, 1. Okay, okay. So here I have directly B plus C is there, and this is B and A. Okay, so okay, yeah, some wrong is there. Okay, So here already it is C, B plus C is there, and we need to, like this A, we need to make a product. So here all the 4 are 0, so by default, so here you will get 0 only, because if any of the term, okay. So in this way, if you do, you will get these two terms. For this first term and this term, both are equal. Definitely it will be equal. It satisfies the law. Okay, so in the next we'll discuss few more concepts.